Welcome back to the third part of our overview presentation of the SET Scan Patternator. In this part, I will be doing a very important topic, which is the quality audit of injectors and nozzles. For a quality audit of injectors and nozzles, the first thing you do is define the objectives of a quality audit. The first objective of a quality audit is to define a few quality parameters that compares different types of injectors, whether they are good or bad. You set tolerance limit for these parameters. So, you have a good nozzle and you can set some small tolerance below and above that to make sure that it falls within that particular use. You generate a master template from these quality parameters. You compare each nozzle with the master template. And once you have compared each nozzle with the master template, you can accept or reject nozzle based on the paternation results if they fall within the tolerance limits for the parameters. Now, what are these quality parameters that you are looking for? There are several quality parameters. The first one is the spray angle. In most applications, the spray angle is one of the most important quality audit parameter. The way the spray angle is calculated is you set the nozzle at a specific distance from the patternator, from the measurement plane of the patternator, and based on the total area that you see, you can find out exactly what the spray angle is. And this is used in all applications to define spray angle, and this is used in standards such as the SAE standard for spray angles. The second parameter is the angular distribution. When you have a perfectly symmetric spray, the entire angular distribution should be uniform. In most cases, your spray will have some deviation from uniformity, where it will go in a zigzag manner around the desired objective. You can define two parameters based on the angular distribution. The first is the total distance, maximum distance, which means the maximum distance any one of these points can be from the ideal, and the second is the average distance. This is a measure of how many of these points and how far away they are from the master template, which is shown here. This is shown as a function of angle degrees, the surface area density. Now, you can go to the third parameter. The third parameter is the radial uniformity. Similar to the angular uniformity, you have a master template that is shown by the line here, and this is a test nozzle, which obviously will move slightly different from the master template. Here again, we have the surface area density plotted as a function of radius. Here too, you can define a maximum distance from the master template as delta x max, that is shown here. You can also define another parameter which shows you how far away you are from the ideal line. This is called the L2 norm. So, once you have so now I have shown you 5 parameters: a spray angle parameter, 2 parameters that define how angularly uniform your spray is, and 2 additional parameters that show how close your spray is to the radial pattern that you are looking for. Once you have these 5 parameters, you can use these 5 parameters to set up a quality audit procedure. So, a typical quality audit configuration is shown here. What you have here is the optical patternator and the spray gun, which is spraying down into the patternator. You have a PC here that collects the data that comes from the optical patternator. It is typically queries a SQL database to find out what the master template value should be, and it compares that with the values that are obtained from here. And once it compares that values, it sends that values over to a control PC, which tells the operator who is standing here whether the nozzle is good or bad. This particular series of computers can all be resident in one computer also. So, this is a typical quality audit configuration, where what you are doing is you are bringing a nozzle to the patternator, you are spraying it to the patternator, you are collecting data on the nozzle, you are comparing it with a master template and deciding whether the nozzle is good or bad. If the nozzle is good, then you put it in a bin and send it out for sales. If it is bad, you reject it or change your manufacturing to account for to get a much better number of good nozzles. Now, what does the sample report generated by the patternator look like? This is a sample report. It will show you the patternation plot, it will show you the radial distribution plot, the angular distribution plot, as well as some sector type plots. Here are the master template limits that you have set up. You have set up master template for angle, for radius, for axial, maximum radial distance. So, several parameters you have set up on your master template, and you look at your measured values, see whether they fall within those different parameters. If they fall within those parameters, then you say the nozzle has passed. If they don't, it has failed. You can give your code, you can give your operator code, nozzle ID, all other sort of information also here. And this is a typical sample report. One look at the sample report, your customer who buys your nozzle can decide whether the nozzle is good or bad, and in which places it is better and which places it's worse. Now we can look at a sample installation. This is a sample installation. This is a 2-computer quality audit system that is implemented at Danfoss in Denmark. This is the Patternator computer. You can see here the contour map of the surface area density, the radial distribution, all in very small images. Here is the Patternator, and this is the control PC. The operator comes here, he stands here, he loads the nozzle onto here. It is an automatic nozzle mount. The moment he puts a nozzle there, it goes to the center of the patternator, goes down and starts spraying. And the patternator takes a look at the data and tells you whether the nozzle is good or bad. This particular booth is designed by another company called Alsmatic, and we supply the quality audit software. You can do different types of nozzles with such a quality audit system, and the typical output is roughly about 1000 nozzles in an 8-hour shift. So similarly, at the end of the line, there are several such companies that have introduced these quality audit procedures for the nozzles. This is very important in the aerospace industry as well as in the automotive industry, and it is getting more increasingly important in the painting as well as the pharmaceutical industry, where coating is starting to become more functional than just cosmetic. Now let me show you some of our customers we have in this field and what they feel about the product quality. The product quality implications, the first thing that they look at. One thing is, in all these cases we have 100% inspections of nozzles are enabled. They have traceable and warehouse data. What that means is the moment they get a nozzle, they know exactly how it performed during the initial test. They have a quick design verification tool. If they have 2 nozzles, they can quickly find out which is better one by just looking at the pattern within a matter of 4 or 5 seconds. They can also sort manufactured nozzles into different bends. So you can make nozzles that are very close to the specifications to be nozzles with for critical applications, and nozzles that are slightly far away from the specifications can be used for non-critical applications. And most of our customers say that they get a guaranteed return on investment within a year. Now, having said this, we can look at who are our customers who purchase this Patternator. This gives you a sample of our customers. Customers are in a wide variety of fields. For example, we have customers who are in the automotive field, tier 1 suppliers like Delphi, Continental, Hitachi and Bosch. We also have their customers who are General Motors, Cummins, MCOM Technologies. We also have other people in the aerospace industries such as Woodward, Delavan, United Technologies, and we have customers in the pharmaceutical field like Ben Research, Pfizer, Boston Scientific, Virtus Pharmaceuticals. So you can see that the Patternator is used in quite a wide variety of fields. It is used in aerospace field, it is used in the automotive field, it is used in the painting field, it is used in the consumer field as well as the pharmaceutical field. Now you can see what are some of the selected comments that we get from our customers. I will leave you with that particular comments, and if you have any questions you can ask me. Thank you very much.